else. Um,
But
and it's possible that they did this. It's possible that they're, like you were saying, they may not have been very sort of compelling entries.
no, but
Uh,
even if you look at impact, to be honest, Hopfield never had much impact. And
right.
the stuff that's explicitly mentioned in
Okay.
terms of Hinton also is not the thing that's the big stuff nowadays.
Okay.
It's both sidelines that are interesting and that always have attracted a small community of devoted followers.
Right.
And I think they're interesting and maybe they're underrated. And yes, they are physics inspired, unlike backpropagation or other things. But they're really not the mainstream deep learning or machine learning stuff that is so successful nowadays. The, who knows? Maybe at some stage, maybe they can become big. But the only current thing that I saw was one of the guys that invented the LSTM, Hochreiter, has a paper where he claims that transformer architectures are more or less a simplification of a Hopfield network to some degree.
Mm,
But even that is a bit of a stretch, and yeah, and
mm,
transformers might actually also already be beyond their heydays. There's a lot of people now working on alternatives that are more efficient,
mm,
and yeah, so we'll see. But yeah, no, I think it's great that they did it. It's great publicity for everything. But as a physicist, I would really be upset.
yeah.
Because basically, it's not even a mathematician who's done some theoretical physics who gets the prize. It's some computer science people who've done something weird, which is vaguely physics inspired. And at that level, maybe, I mean, physics, pretty old fashioned physics, like 200 years old physics. So it
Yeah.
is, I was doubly surprised seeing that this morning. I still can't get my head around it. Those two, one thing I said was that maybe it just shows there were no good other combinations. Maybe physics has a problem. Maybe physics has reached a stage where they ran out of ideas and they're really just waiting for the next big thing and it hasn't happened yet.
Mm. Yeah, I mean, there's actually a big field of AI or neural networks that are physics informed.
Yeah, no, there's a lot of stuff happening with partial differential equations and stuff like that. Yeah.
Yeah. So why not them? If we are so eager to put AI into it.
Yeah, yeah. I don't know. Maybe next time.
Yeah,
But
yeah,
at least
exactly.
now,
Now that's the field
instead
we
of
should work
Turing
on.
Award, now you can also win the Nobel Prize for your AI work.
Yep.
It's cool in a way, but really, really surprising.
Mm.
Anyway, let's get back to some cybersecurity, which might also have
Yep.
physics potential. Who knows?
Yep. Yep. So I need to have the privilege to share.
And you should have that now.
Cool. So let me see if I can. Did you show it?
Yeah, yeah.
Yep.
All right. Cool. So so the first thing I have done is basically figuring out what's the optimal amount of data for the whatever we call the large language model. So there is a paper from Google DeepMind just come out this year for RCLR. They're talking about the this issue exactly. So they examine the effect of data, of model fine tuning, blah blah everything. So basically, in their proposition, I find this one particularly interesting. So they come out a law, uh, yeah, which really I think should be a proposition rather than laws, because it's based on imperial results. These are like their own words. Yeah. So the loss of the model or any task should be dependent on these parameters, namely the A, E, alpha, beta, that is task dependent. You need to figure out by yourself.
But
And
are
then,
these parameters, I mean, what do they stand for? Do they have some relationship to the size of the data or?
yes, so the other parameters like the X is actually, what is X? Probably the model. Yeah, something like that. The DF is the fine-tuning data size. So
Okay.
yeah,
Data and F for fine tuning.
yeah, that's interesting. They didn't mention what the X is, but basically the loss is
The X is some is it F is the number of parameters in the model.
yeah, that
Which is
feels
the capacity, having one over that kind of should be related to the error. If you have more capacity, you should be able to get a lower loss.
yeah. So here they are saying X refers to each of the other scaling vectors.
Interesting. Okay.
Yeah, so
Yeah.
it's just everything else.
And do they say anything about ranges for alpha and beta for the coefficients?
No.
And do they say anything about what the A stands for?
Uh, they are saying they are called data specific parameters to be fitted. Maybe it's a little bit too small here. Yeah.
To be fit. Okay. So basically, they have no direct interpretation. You want the
Yeah.
multiplicative factor for these fractions, and then you have some irreducible error E provides
Yes.
for error, and then alpha and alpha and beta. I see that you can probably estimate it from the data. Okay, and then with the A it's more flexible. Yeah, okay.
Yeah. So
What's the relevance of that for your work?
so basically we are trying to find optimal data size for fine tuning. So the final conclusion would be it's just too much. It's way beyond what we have. So
I would say the same. I mean, the general, very simple heuristic is more is better. But
yes.
I guess the main question is how much is enough?
Yes. So there is another paper from 2020 kind of answers that. Uh, this is from OpenAI rather than DeepMind.
Mm-hmm.
So they have some kind of a scaling law as well, which is similar to the DeepMind's scaling law, but with a more strong math. So they give an exact number, 8.8 multiplies basically 10 to the power of 13, which is, I don't know how many billions. Yeah, so basically they are saying your loss will come to 1 if your large model parameter is closing to this number.
You mean the loss comes to 0?
Yes, they also come to 0, but if you have a model, let's say your data set is relatively fixed, if you just scale up your model, and if your model is approaching this, and then your loss is close to 1. So that's what they observe, kind of thing. And then apparently they always come to smaller numbers as well. But this seems to be a good spot for the efficiency-wise consideration. Yeah, again, these are, I would not call them law. Rather, they are more like a observation. I don't know why they named them law. Really, it's more like a observation or something. And then they gave some concrete solution for improve model performance. Basically, you have three factors: compute power, data size, and model size. And so they have a proposition here in the big three: optimal, compute efficient training. Most of this increasing the effort should go to the model size. So basically, yeah. So there's a um, size matter rather than the size matter of the model rather than the data size. That kind of gives you the most return. Yep. So they also have a bunch of interesting questions like which setting has few impact on the model performance. So basically, for example, you can tune your model with different weights, different depth. That doesn't matter too much. And also, if you have either your model size or your data size is held fixed, you will have diminishing returns. So in other words, if you just simply increase your computer power and not scaling up your model or data size, then you are basically wasting money. And another interesting finding that relative to us is basically this. So large models are more sample efficient than the smaller models. There is a nice figure for it too. Yeah. So the sweet spot here is 10 to the power of 3 parameters. For the tokens processed. So if we have anything that close to thousands of data, actually, let me see. It should be,
If I look at this,
yeah.
I don't see what they claim you should see here, because what I see is that after enough tokens have been processed, the smaller model plateaus at, or converges or levels out at the loss of about 6.
Yes.
And the much larger model, the dark blue one, is able to achieve a loss of 2. So
Yes.
something I
So,
would expect, if I have enough data, that a model with more capacity gives me a better loss at the end.
yes.
And maybe the interesting thing is, maybe this is what they want to highlight, is that the blue comes down earlier and quicker.
Yes. So that's what I was about to say. So if we have
Yeah,
like thousands of data, and then in other words, it's more efficient in the early stage.
yeah,
And
yeah.
for the smaller model, it's not going to do anything until we have like millions of data
Yeah,
samples. Yeah.
but I think what you what's not clear here is the smaller model might be a lot faster in terms of every single times per token processed.
Right.
So this is 10 to the, what's that? Is that 10 to the nines or something in the middle? So the small model might be there
Yes.
much earlier than the complex model. And
Oh,
so
yes. So time-wise, there might be a different argument. Loss-wise, so more like accuracy-wise.
yeah, sure.
So yeah. So the efficiency should be like on the performance rather than the training efficiency.
Another what I don't know is they seem to equate number of tokens basically with number of unique samples. I would think. I don't think that they actually, like with
Yeah.
small data sets, you train for many epochs with the same data again and again. I think what they basically do is they go through the data once and they have a large amount of data. Because this is what you see with the really large language models, that they basically talk about, I don't know, they have 3 times as many tokens as parameters in the network, and they just go through everything. And yeah, it takes forever, but they rarely come back to the same data again.
Ah, okay. So
So it
they
was
do
just
multiple
interesting
efforts.
what they've actually done here. If that is the same data set with multiple epochs, or if there's just one
Yeah.
data set that gets larger and larger in terms of number of tokens that they have on the x-axis. I think that would be
Ah,
interesting to
okay.
find out in the paper what that actually means.
So
Because
the
I mean, if
token.
it is the case that it's only going through the data set that gets larger and larger, then yeah, it's true that they have improved loss early on.
Right.
But
So
and
yeah.
another thing that's also true is that's maybe the interesting thing here is that once you hit the capacity of the network, the small one, more data doesn't help. I think
Exactly.
from my point of
So
view, this is probably the most interesting feature in this graph, that you level out around 6 with a small model. Even if you add millions of more tokens, billions,
yes.
it's just you hit the wall basically. There's only so much that this smaller model with 1,000 parameters can store. Which I guess makes sense if you think about it. I mean, if you have limited capacity, then at
Yeah.
some stage you fill it up.
It's like we're asking a chimpanzee to do physics. So it's just beyond the capacity
Yeah.
of the model. Yeah. So yeah, so the takeaway here that is kind of relevant to our research is our data size is nowhere close to this. It's like if we want to go with the fine-tuning approach, we have to do a lot of data along with model experiments. So yeah, I think that's we need for that we need like 20 people of different groups. One like one of the 10, one of the groups like 10 people working on the parameter size. The other 10 working on the maybe increasing data samples, and some other people is purchasing more computational power. So and then do the experiments. That's more like the fine-tuning approach for this labeling project, and that doesn't look very realistic at all. So after that, I started looking into how about we do this as a few shots or zero shots task, or even more ambitiously, we put it online. Just don't train anything. Throw it in the data spring, see what the model does. So that seems very realistic to us. Yeah, then the first challenge that we have here is there are multiple ways of labeling the same CVE. It's all depending on your span selection. And that also leads to different labels, different amount of span selections. So we'll see something in the example here. So what I did zero shot experiments with these 3 models. The ChatGPT one, we have a slight problem with billing. We'll get to that later. Yeah, so basically I crafted something like this. This is our prompt. So I tell them what the task is. I didn't really explain what these aspects are. So this should be a challenging part for the model. So they need to figure out what these aspects are supposed to mean, and it's very domain specific.
Is it really called a stand-off format, or do you mean a standard format?
The standoff format is a naming convention from Brett labeling tool.
Ah, okay.
Yeah, so it's like I remember one of the Weka has something similar too. So in Weka or MOA, we have this standoff. So basically a file format. They just call it standoff format. Yeah, so in other words, I asked the model to output something that can be directly usable in the bright labeling tool for visualization, not just give me the labels and stuff. So yeah, so this is the template to explain what everything is roughly, and then show a format, and then ask it to do it with this. That's actually the first sample I labeled in our dataset. So here are the reference. This should go to this. Local privilege escalation, effective products, VCs, and AP. Later on, a lot of the models have some problem with this. So they are thinking this could be an attack vector. That's exactly why I figured that I didn't explain the aspects well enough. It's actually highly confusing for human too. So after digging through different papers, the short story is, if you think this thing is relatable to the victim system, then it's effective product or vulnerability cause. And if that something has to be applicable to the attacker, then that's attacker vector stuff. So for this VSOC transport support commits, so basically this code created the problem. So technically it should be effective product. And then a lot of the model will confuse this as attack vector because they think this is where you put the exploit code. Yeah. So here is the latest effort from Google, Gemini 1.5. And they also,
VSOC is a well-known library. Um,
yeah.
it's known to be a product.
Wait, what's that?
Why is there ambiguity in that?
Oh, so Linux kernel has a VSOC implementation called VSOC multi-transport support.
Yeah.
So that's the product is this code,
Yeah,
not
yeah. So
VSOC. Yeah,
that's fine. I'm agreeing
yeah.
with you. I'm just trying to understand. I mean, I think um, this information, as far as LLM is concerned, I'd expect the LLM to know this.
Yes, the M does kind of know.
Okay.
Um, some actually, we can see it here. Yeah, this one knows, like the latest one from Google. This is the smallest model from the Gemini 1.5. So it's like a dev model. This one knows it well. It's saying there's some VSOC implementation problem. And it correctly identified that as not an attack vector, the vulnerability cause. So the confusion comes from, so now if you are trying to hack this system, where you put the code, where you start attacking, what's your attack surface? So technically should be this, right? So there's something wrong with this locking system, which cause risk condition. So you must be doing you must inject through the interface that eventually leads to this. That's the confusion. Like the language models, they understand what these things are. It's more like they don't know the concept of, okay, what is the attack vector? What is the difference between, what is the difference of that between attack vector and vulnerability cause, because these two things, even to human, can be very confusing. So the attack vector here is not actually shown. So now imagine you are trying to attack this. There might be some kind of a command line that takes this input. And eventually, after they process the exploit, that caused this line will be run too, and then which is causing the problem. But this doesn't make this the attack vector, because it's no part of the interface or where the ejection go to. Yeah, so yeah, this one works fine for the first one. Yeah, even at 0 shots, you just this is the first run. It shows the span and everything. Looks good enough to me. So made some notes. So have some careful examination. These things are off. This is actually just off by 2, I think. Yeah. Wait, hold on. Off by a lot, actually. So because this is not this. Yeah. So this one is off by 2. The VI, vulnerability impact, is off by 2, and this is off by a lot. Yeah, so the spans are off, and you will see this a lot in the later models. And this one is surprisingly to me that the format is actually correct. Yeah, normally I was thinking it will output something broken, but it's actually correct. They have different labels, so after reading this, they treat this as labels automatically. And if you try to compare these two, like see if they match, actually they do match. It's just that the spans are split into 3 spans. So that comes back to the very first challenge I mentioned earlier. Yeah, if you treat this as a 1 whole span, which is I normally do, so this whole thing is just one selection, and you only have one VC. And then again, this model treats this as multiple span. Yeah, which is correct. Yeah. Now, for some reason, it puts the VI in the very end. Logically, it doesn't make sense because they see the escalation first. So technically, it should be something like this, like the reference. Yeah. So I noticed this. This arrangement, like APVC, VI, AC, AV, is the order that I normally present. So logically, I think this way. So there's vulnerable product, vulnerability cause, then what's the impact, then how to attack. Or sometimes I swap the last 2. So maybe that's why they took this order. Yeah, maybe that's how I explained it too. Yeah. So they took the order of this one, instead of using the order of saying in the sample. So the span order has a little issue. Yeah, but other than that, this is a perfectly fine evaluation. So I was like totally surprised. And then I tried it again. I don't want to believe this. So yeah, on the second run, because it's a chaotic model, it does something different. I remember this one was more like through a API rather than through a chat GUI. So in other words, there's less parameter optimization involved from the front end. So I just threw the default values and stuff. Now it returns something different. It only picks a couple words. So Linux kernel, and the version number comes at the back. And now here's the problem. It treats the VSOC support as an attack vector. So yeah, and it gets rid of some like a privilege escalation. I believe is a local removed. Yeah, so it started to do something random. But more or less they are kind of consistent. And the format is actually correct, but the indexes are wrong. They are all treated as.
What do you mean more or less it's correct? I mean, is it reliable?
More or less correct in the sense that, so the most important thing, in my opinion, is the label and the selected span. So in the final visualization, if we color coded it correctly, this will look correct. So this doesn't really matter actually. This T1 or 2 and 3. So this will not be a matter. And this span will not be a matter neither, because we're technically just treating the labels and the NLP stuff, or the text stuff.
Okay.
Yeah. So in that sense, they are reliable, but in the format of standoff from the breadth labeling model or labeling tool, this is wrong. First, it will be a syntax error. Second, there will be a text span off problem. So this is off by a lot. Yeah. And then I got a little more ambitious, expanded everything from our data set. So I sampled 9, so I started a little small just to cut down the cost. Yeah, it's probably costing me $1 or $2 to run this. Yeah, I will bill you later on this. That's how much it costs. So,
But you
yeah.
can use the account, right?
A what?
You can use that Crolab account.
Colab, yes and no. Yes, in the sense that for the free versions, like they have some free versions available. I believe maybe this Flash, yeah, you can do this.
No,
But
you're just talking about the ChatGPT one,
oh, this is not the ChatGPT one. This is the Google one.
Gemini. Okay, right.
Yeah. So for ChatGPT, yes, more or less we can have some kind of a loophole, and then get through the paywall somehow. But yeah, so I basically expanded to everything. And this is model accuracy. So as a comparison, our BART model is doing 60-some% with the label accuracy. With the selection span, it was doing something 80%. But again, it's just 9 sampling. So it's doing 3% with 11% recall. And yeah, just across the board. So in other words, the model does output something meaningful to the human eyes. But if we are ambitiously asking it to output functional code to the breadth labeling tool, it will not work. Yeah, personally, I think maybe if we keep human in the loop, this is good enough. But if we take everything out, make everything automatic, this is not good enough at all. So yeah, I'm thinking keep doing this for the everything, so 450. And then there was a weird issue with sampling because in our paper we split them into 405 and 50 and 45. 405 as training, 45 as testing. So that is done through a script inside a Kaggle notebook. So I need,
wait, before we go, I'm just looking at this and thinking. So you say nine
yeah,
samples from 450,
yes,
and then you say average label accuracy is 8.3.
yes.
How does that work? Like, if you have 9 samples, how do you get an average label accuracy of 8.3?
So let me show you the code. It's a fairly long story. So let's go into,
Yeah, but and if you look at the other numbers, then they're all 0.1111. So this means 1 out of 9. If I see this as fractions and not as percentages. So for
yes.
all the other things, you use fractions before the accuracy. That's a percentage. Because
Yes, yes.
but how do
That's
you get?
actually what I did in the paper too. So
But
I
how
did
do you
that.
get 8.3? Which let me just try if I can get
Yeah. So it has something to do with the coding here.
I can get 8.3% accuracy if I get one correct out of 12, but not 1 out of 9.
The trick is average sample might have multiple spans. And this is,
Okay.
yeah,
I see. Yeah. Okay, that's a different story then.
yeah.
Okay.
So for example, like this sample, it
Yeah.
has 5
So
spans.
sample does not necessarily mean the total number of decisions or predictions.
Yes.
Yeah.
So that's the tricky part here.
Then forget about it. That's fine.
Yeah, yeah.
I understand now
So
how you can get those numbers. Okay.
yeah,
Makes
it's a
sense.
little bit odd. So that's why I put them into a more like a 100 based instead of decimal based, just to remind me that they are not the same conventional computation. Yeah. So that's the short explanation. They have multiple spans, and for each span, we need to calculate the accuracy. Yeah. So there's some fuzzy, blah blah, everything involved. Yeah. Yep. So let me reshare this. Yeah. Yep. So with that, I expanded. I was before I hit the bigger bill, I was thinking, okay, how about the pro model? If the Flash model is good enough for human in the loop scenario, how about the pro? So the first run, it does something very strange. It didn't output the standard format. It directly labeled onto the description. So almost like it's designing itself for human in the loop scenario. Yeah. So yeah, identify this as the privilege. Yeah. Actually, if you are looking at the CWE website, I mean CVE website, this should be very familiar to you because this is how they are doing it. So in their CWE labeling stuff, they just put different CWE into the description. So the model did something very similar. They put the labeling here, label here, and here. Yeah, and technically this whole thing could be put into a VC, but yeah, we decided to put multiple risk conditions, which is true as well. Yeah, so the first run it did something like this. And then I think he could do better, so I ran multiple times, and then there's second run. He did something strange again. This is not exactly the standard format, but very close to. To get to the standoff, we need to get off this kind of a markdown looking stuff. This is the raw output, so it's not processed at all. And they put some kind of a anchor just to show that this belongs to one entry. So in other words, it feels to me the model is almost too smart. It decorates a little bit for human looking, not for the breadth labeling tool. And another thing is apparently this will throw standoff format error syntactically, but semantically, this should be in the front. And everything else looks fine, other than this weird looking thing. Yeah, so that's the pro model. So long story short, it's more like designed to be human in the look. So it's almost too smart. You will know, oh yeah, some people will look at this. Let's make this beautiful. So yeah. And then I tried with the ChatGPT 4o, the latest one. It outputs something like this. So the problem here, the AP is too short. You should include versions. So technically it's wrong, but almost like half wrong. It identifies there's something wrong with
It was only code 5 for 8, right?
I think the reference is indeed 5.
Oh, okay. So
Yeah.
why do you get 8 with Gemini?
Because this one is just spanning the text span issue. So if you put this together, you got 1. Yeah.
Yeah. Okay. So 5
So
is
it's
the better solution. Say 5, not 8. Yeah. Okay.
yes.
Yeah. Okay.
So for the human eye, 5 is better. Maybe for the tooling, maybe this is better because it's more precise. Like this select this part of the tokens. Yeah, and then this one is like too short, but the span selection is
If you don't mention the version number, which Linux kernel are you talking about? Not all of them, right?
yeah. Yeah. So and then this model trips around the impact and attack vector, which people do that a lot too. So someone can say this is how they the funny thing is actually this model even output an explanation. So it does some of those XAI stuff. It was saying because this description is telling you can exploit this vulnerability through local privilege escalation. Therefore, this is an attack vector. Yeah, sounds a very convincing guy. But I don't really agree. So there's a confusion between these two. And then the text meta off. And now here we have the billing problem. So he's complaining I don't have a sufficient quota from our so apparently they reworked the whole front end and the back end. So it's very different from what it was 3 years ago. And now they have a different billing system. And they were saying I don't have enough quota. So that took me a while to figure out. This error is actually very confusing. So it can be anything. But this documentation doesn't help neither. So what really goes is we need to put money down first. So because we didn't have any credit balance, our API calls will be shutting down. So in other words, we need to put like $1 or $2 here first, then we can start experimenting. Yeah, so very sneaky way to get money from us. Yeah, so that's all for the experimentation. Yeah, so Wimo, if you can, yeah.
We can do that. We can put some money in that.
Yeah, just like $3 or $5, something like that. It should be good enough to get rid of that error. And then I tried one shot as well. So the similar prompt, but I put an example here. Right, so description, output. So, and then, yeah, so basically I took another example, show the output first, and then ask the same prompt or same description. And then the Gemini output something like this. It's technically wrong in the sense that there should be a new line. It could be like this. Yeah, but a new line like this. So for syntax wise, so everything starts with T something. And also the first one is wrong. It should be impact. Oh, actually, it should be yeah, impact. Was it impact or vulnerability cause? I think vulnerability cause. Let's go back and double check. Make this thing smaller so we can see the reference better. Yeah, impact. Yeah, then now I'm confused as well because this feels like a root cause as well. So it could be VC. Yeah, so go back to this one. So it's auto putting this. So this is definitely wrong. This is wrong because the label is wrong. And then vulnerability cause. This is also wrong because it should be this two seems to swapping places. Yeah, this is correct. This is correct. Correct. And correct. Yeah. So the span again is going wild and random. So you has 9 text spans. And the indices are off. So in short, the syntax is wrong, some semantic error as well. In other words, the model seems not improving too much from this prompt, from this one-shot case, but it's getting the idea of standard format. So the formatting is better, but not by a lot. Yeah, so this is the pro version. Correct. Correct. And correct. It's doing everything perfect, except the the indices are actually correct. It's just longer. Yeah, so the pro version is doing everything fine. So with one-shot setting, with Gemini Pro, not the Flash, not the development model, it's doing very good in the sense that the labels are correct and even the indices are actually following. So this could be a functional visualization of the breadth labeling tool. Yeah, so that's all the experiments I have done with the few-shot learning, and feels very promising. Especially with the one-shot German model, because we don't have the billing stuff going on. I didn't try the ChatGPT or the OpenAI version. So, but the Google Pro version, which is also behind paywall, is doing really well, almost too well. Yeah. So,
Stay behind the paywall. Do you know how much it would cost?
they have a really weak wording, but from my experience, we're looking at something like a quarter for this example or something like that. So if your input is crazy long, it can easily go like sky high, $200 for the whole data set or something like that.
Okay.
Yeah. Uh, yeah, but that thing is changing dynamically. So Google is just give you a bill saying this is the final call, and they didn't really explain the rationale. I think it has something to do with their data center and how their cost center is computed, everything. It's not too bad. It's acceptable comparing to I don't know, human counterpart. If you now imagine the potential here, if we put this online, this with one-shot learning with the pro model basically will do it. And uh, from what I have known with the CVE, we are looking at 100 something each day for CVE. And you need like something $10 ish to have a real-time evaluation. To me, that's very attractive. Rather than waiting for half a year and then everything is defeated. Uh, and then you've got a score that's possibly wrong and everything. Yeah, so so this actually give me some inspiration with the online learning version of this language model for our task. Now I can also expand this to the CVSS and CWE. I'm tempting to see like how that performs as well. So if everything performs fine, I can combine all this into one task. So in one output, you will do all this. Like I'll give you this, give you CVE rating, and then you have an online system that works just fine. Yep. So that's all the.
What about the consistency? Like you mentioned earlier, you put the same description and the spans are different for the same sort of matrix.
CVE. Yeah. So that is caused by the searching space and also by the temperature, which is actually the inevitable engineering involved later on. So we need to find the optimal temperature manually and task specific. Actually, there's one easy thing everyone can do. If you put temperature to 2 in ChatGPT, it will generate gibberish just to every single task. And then if you put too low, it's just so deterministic that it's not even interesting to look at. Yeah. So for that, we have to find this sort of a sweet spot that is working fine for us, interesting enough, but not too boring that it doesn't generate anything meaningful.
Right.
And if it's going too much, yeah, it's just an engineering problem, to put it short.
Okay.
Yeah. So there is a sweet spot involved, and I'm just borrow Google's parameters, and it seems working fine with the pro version. and maybe it's dependent on the model size as well. Yeah, so that's so far what I have done with the experiments, and then I dig into some of the uh, theory side. So this is the GPT-3 paper. Show you. Yeah, so their few shot linear claim, the in-context learning, and we have seen it, I think last week. And then there is another sort of online learning paper, which I find particularly interesting. This is very similar to what we have done with our data stream mining class back to like 2 years ago. So basically, the digging into Twitter, find a data stream, and mining that, and then, but the difference here is to use a transformer model. I haven't finished everything. Literally, I actually just started this one. Yeah. So basically, the takeaway that sort of interested me was like the model size. So basically, the bigger the better. And then it's a little dated. So they're talking about T5 better, not the Gemini or the new GPT-4 better. Yeah. So yeah, so that's what I have done so far for the Evo as an online learning task. Yeah, I think we should finishing up now because we're running out of time. Yeah. So I was looking into the presentation. So for the PhD conference coming up, I think.
Yeah.
Yeah, and then I guess we'll look at the review next week.
For the PhD presentation, you can present. You don't need to present everything. You can maybe present just one of your papers, either the journal paper, or you can present um, the one that's sort of sent to NSS.
Okay, I see.
Yeah, so you can just
Yeah,
do. You don't need to present everything on that PhD.
I see. So I was trying to be very ambitious, present the final thesis. So I was trying to present the alternative kind of thing for the everything. Yeah.
You can do that as well. I mean, as a dry run of maybe 20 minute presentation before your oral defense, when not defense,
Oh, okay, yeah.
you never, but there's a long time for that. So
Yeah, yeah, I see. Yeah, I can make this short and just focus on the key ideas. Yeah, and then just hear what they say. Yeah, should be good time. Yeah. So there's that. Yeah, so that's all for me. Questions so far?
I mean, you mentioned your thesis. How's that going?
The thesis is, so basically I slept around the paper left over. So it's still like, I don't know, 20% down kind of thing. Still a long way to go.
Mhm.
Should I hand it in within a time window somewhere like this year or next year? Like what's the procedure we are looking at?
When does the scholarship come out?
I think it's by the end of February next year, something like that.
So ideally, you would submit by that, but it's probably already quite close in a way. But I don't know. Do you think it's realistic for you to finish your thesis by end of February?
Yeah, that is very doable. I mean, I can even try something more ambitious, like by the end of December, something like that.
I mean, it's good to have a kind of an ambitious target and a little bit of slack to be able to extend beyond that. But yeah, no, I mean, if we want to plan for more or less the end of the year, that would be great. Yeah, but you do
Yeah,
right.
okay.
I mean,
Yeah, I mean,
you're aware of the fact that the end of the year is like only 2 months away, roughly.
Yeah.
I'm away from mid-November to end of December. So I
Ah,
wouldn't be able to look at anything and give you comments. And
so
so, I mean, I could try finishing up a complete close to
Draft,
worded.
yeah.
Yeah.
complete draft by that by end of December, and then we can kind of improve it
Yeah.
uh, as we have more time.
I think that sounds great. This is a good plan.
Yeah. Okay, I will go do that then. So 2 months, the first month I will put everything from Evo, and then everything else from the CWE stuff I can put on the next month. Yeah, then I need to put the last couple ones. Yeah, looks a little rushy, but I will see what happens.
Cool.
Yeah. All right. Thank you, guys. So for the next
Yeah,
week,
good stuff. Yeah.
thank you. So for the next week, what should we do here? Should I keep on experimenting with the few shot stuff, or should I focus on the writing side?
I mean, for the
I'm
future stuff, it would be good to also have some quantitative reasons, like an accuracy score across the full data set or something like that, so that we can
yeah.
also get an idea of. I mean, right now we've seen some very good anecdotal evidence that it seems to work quite reasonably.
Mm,
But in addition to those examples, you always want to have some numbers.
yes.
Numbers would be good. Um,
Yeah.
Writing is also a good goal. So, from my point of view, what are you in a good writing space? Because writing to me seems to be sometimes it works really well and sometimes you're struggling to write. So whenever you're in a good space for writing, you should exploit that and write as much as possible
Gotcha.
while
Yeah.
the writing flows. But if you hit a kind of little wall there in terms of the writing, then going to running some experiments is a good alternative.
Yeah.
But again,
So
I would prioritize the writing, to be honest, because right now that seems to be the most important thing.
I see. Yep. Okay. So in that case, I will um start it more like writing everything what I have presented down, and then see how the thesis goes, and then yeah, if there's anything missing, I will do some experiments accordingly. All right. So for the next week, I will basically write everything down and um, put down the paper from the eval, and also along with the reviews. Yeah. All right.
Yeah, sounds good. Okay,
Thank you. I will see you next
very good.
week.
Yeah, bye bye. Have a good week.
Bye bye. Oh.